STA 2322 Data Analysis Using Statistical Packages. Lesson 8 Contingency Table. Learning Outcomes. Know types of contingency tables. Calculate row totals, column total, grand total and expected values. Know manually calculate the chi-square value. Read the chi-square table value. Perform cross-tab using SPSS. Understand different output tables. Contingency tables. Contingency tables are data tables which are created whenever categorical data cross-classified. When we are using the categorical data, we have to use the contingency tables. This occurs frequently in the collection and presentation of social survey data based on interviews, questionnaires and secondary sources. It means when we are analyze the data using the mainly qualitative values, it means qualitative data. So if we can convert some qualitative data into the numerical values. In that case, we can use the contingency table in SPSS to interpret the collected data. Categorical data are generally thought to consist of two distinct types of measurement. Nominal measurements, simple counts, labels and names. Examples: male, female, British, Irish, American, Sri Lankans. So those are nominal measurements. Ordinal measurements, counts, labels and names which exhibit a qualitative relationship or rank order. Example: lower class, middle class, upper class, good, indifferent, bad. These types of categorical data, that nominal measurements and ordinal measurements, we can use in those contingency tables. Terminology and notation. Two-way table. A contingency table created by the cross classification of two categorical variables. Here there are two categorical variables. One is gender, the other one is age. So in that case, there are some you can see young, age can be divided into young, old, and gender can be divided into the male and female. This is a two-way table. You can see the column totals and row totals as well as the grand total in there. Similarly, there are three-way and four-way tables. That is this one is two-way table. Similarly, we can have two-way and three-way and four-way tables. This is a four-way table. Here you can see there are 4 columns and 2 rows, and 2 into 2 contingency table. A two-way contingency table is which each variable possesses 2 levels. So this is a two-way contingency table. So you can see right hand, left handed, then males and females. So this is a two-way contingency table. 2 into 3 contingency table. So you can see here there are 2 columns and 3 rows. Sorry, 2 rows and 3 columns. This is 2 into 3 contingency table. So number of rows into number of columns. 3 into 3 contingency table. So there are 3 rows and 3 columns. This is 3 into 3 contingency table. Cell or elementary cell. The cross classification of 2 binary values created 4 possible types of combination. Example: so here this is a 2 by 2 table. So here, so you can see there are two levels. So you can see there are 4 types of combinations: young male, young female, old male and old female. Right? So these are the combinations: young male, young female, old male and old female. So these combinations are the cell or the cells of contingency table. Similarly, a 3 by 3 table will have 9 cells, and a 2 by 2 by 2 table will have 8 cells. So this is 3 by 3 table. So what are the possibilities in there? Here, tall, medium, tall, short, and medium tall, medium short, short tall, short, medium and short. These are the cells. So this is 2 into 2 into 2 table. So here you can see alive, early, high, alive, early, low, alive, late, high, alive, late, low, and dead, early, high, dead, early, low, dead, late, high, and dead, late, low. These are the cells. Observed cell frequencies. So the numbers of individuals in the sample who are classified in each cell. 20 output of 120 respondents in this table are classified as young male. Young male is this one. There are 20 responded out of the grand table is 120 classified as young male. Expected cell frequencies. The numbers of individuals in the same who would be classified in each of the cells if a particular hypothesis above the table were true. These are the expected cell frequencies. Grand total. So grand total, the total sample size, for example 100 in above table. So you can calculate here, that is a column total. This one again column total. If you add these two, you can create 100, and as well as if you add these two in rows and take here again the same value, you can take as grand total. The row and column marginals. The total number of observation in each of the rows and columns of the table. In the above table, marginals are 52 and 48 row marginals, and column marginals are 87 and 30. Chi-square test. Now we consider how we can do the chi-square test to the contingency tables. The chi-square test is used to determine whether there is a significant difference in between the expected frequencies and the observed frequencies in one or more categories. Do the number of individuals or objects that fall in each category differ significantly from the number of you would expected? This would be the this will help to write the hypothesis. So what we can write the hypothesis in as null hypothesis, where we can write there are no significant differences between expected frequencies and observed frequencies. And so then alternative hypothesis, we can write there is a significant difference between the observed frequencies and the expected frequencies. Those are the null and alternative hypothesis for the chi-square test. Chi-square test is a non-parametric test of a statistical significance for bivariate tabular analysis. So all the other tests we considered earlier, those are the parametric test, but chi-square test is a non-parametric test, which is going to discuss in this course, but you can learn more non-parametric tests in the next semester. You have a separate course called non-parametric methods. So but chi-square test, remember that this is also a non-parametric test. Chi-square test requirements. These are the requirements. Quantitative data. So if you take the qualitative measurement, you have to convert into the quantitative data, otherwise you can't you can't perform the chi-square test. So quantitative data, one or more categories, independent observations, adequate sample size at least 10, and simple random sample, data in frequency form, and final one is values. Categories on the independent and dependent variables must be mutually exclusive and exhaustive. So the dependent variables and must be the mutually exclusive and exhaustive. I think you remember those terms because you learned those things in introduction to probability theory. So mutually exclusive and exhaustive. What is the meaning of mutually exclusive? If we take sample space equals 1 2 3 4 5 and 6, and we take some events a equals 4 comma 6, these are sets, and b equals 1 comma 3 comma 5, and c equals we take 2 comma 3 comma 5, right? If we take c as 2, 3 and 5, right? So what is the meaning of mutually exclusive? If we take a intersection b, are there any common values? No. So that is that is 0, no? Sorry, that is null set. Therefore what we can say, if intersection is a null set, we can say a and b are mutually exclusive, right? Mutually exclusive means there is no intersection. And as well as if we take a union b union c, what is the value? A union 1 is there. If we union, we are taking 2 and 3, 4, 5 and 6. So what is this? This is equals to the sample space omega. So if we take a union b union c, if it is equal to the sample space, we can tell a, b and c are exhaustive, right? So that is the meaning of mutually exclusive and exhaustive, right? Then here the last requirement then that is the variable should be mutually exclusive and exhaustive. I think now you have the idea about what is mutually exclusive and what is exhaustive. One-way classification of chi-square. So the one-way classification was sometimes referred as a single sample chi-square test, is one of the most frequently reported non-parametric tests. The test is used when a researcher is interested in a number of responses, objects or people that fall in 2 or more categories. This procedure is sometimes called a goodness of fit statistic. Goodness of fit refers to whether a significant difference exists between an observed number and expected number of responses, people or objects falling in each category designed by the researcher. The expected number is what is the researcher expect by the chance or according to the some null hypothesis. So that is expected value. So example for the one-way classification. Now we consider what is one-way classification through an example. Our customer equally prefer 3 types of car. There are some data given. Customer are classified only one way by car type. If there are an equal preferences, we would expect each car to have 33% of vote. The expected values are given here. What is it? 33%, right? How much do observed frequencies deviate from the expected frequencies? This is the research question. So based on these research questions, we can write the null hypothesis and alternative hypothesis as explained in earlier. So what is the null hypothesis here? There is no significant difference between the observed frequencies and the expected frequencies. And alternative hypothesis, there is a significant difference between the observed frequencies and the expected frequencies. A random sample of 100 customers are questioned and asked which car type they prefer. So then these are the these are the collected values. Then expected values also given, because they told that there are equal expectation. It means 33.33, because if you take all together 100 and expectations given here, right? You can't find this because this is given, so you have to write 33.33. These are the expectations. So this is the equation to find the chi-square value, that is observed value subtraction expected value square divide by expected value. Then you can take the chi-square value, where O is equal to observed values, E is equal to the expected value, and the, this is chi-square. Right, now we will see how we can do the chi-square test, one-way chi-square test manually. Right, we have the observed frequencies that is given in the question as 45, 30, 25, and the expected frequency is given as 33.33, 33.33 and 30.33. These things given in the question. So what is equation to find the chi-square? Chi-square value is equals sigma equals to sigma observed frequency subtraction expected frequency square divided by expected frequency. So then now we need to find so if we take the total of this, that is come as 100. So this is total sigma. If we take the total of this is also equals to 100, and first we need to find observed value subtraction expected value, then we can square this. Right, we can use the calculator. So what is our observed value? 45 subtraction expected value 33.33, then finally we have to square this value, then it's come 136.1889 means 136.19. right, so next one is 30 subtraction 33, sorry 33.33, no, 30 subtraction 33.33, it is come as minus 3.33. then we have to take the square of this one, that is 11.0889. it means we can write 11.09, and last value, that is 25 subtraction 33.33, and we have to square it, then it is come as 69.3889. so we can write 69.39. right, then we have to find square divide by expected value. right, so if divide by expected value, so it means 136.19. what is expected value in here? 33.33. so 33.33, then we can take the value as 4.086. it means that is 4.09, and next value is 11.09 divide by 11.09 divide by 33.33, that is 0.3327. we can write this as 0.33. the last one is 69.39 divided by 33.33, the value is come as 2.081. so we can write the value as 2.08. then we have to find the total of this 4.09 plus 0.33 plus 2.08, the value is equals 6.5. right, so this is the way of finding the chi-square value. we found that chi-square value as 6.5. right, chi-square value is 6.50 then. right, then the hypothesis testing steps. Preferences are equally split among three car types, that is given, that's why we taken this as 33.33. the preferences are equally split, it means 100 divided by 3, 33.33, and null hypothesis is observed value is equal to the expected value in population, and alternative hypothesis is expected value is not equal. it means there is no significant difference between the observed values and the expected value. then here there is a significant difference between the observed frequencies and expected frequencies. specify the decision rule, so alpha equals 0.05. so then here also we can find the degrees of freedom. You can see there are n equals 3, there are 3 observations, then degrees of freedom is equals to groups subtraction 1. This is 3 minus 1, that is equals to 2. So then you can find the chi-square values using the table. This is the table alpha level. What is our alpha level? That is 0.05. This level, first you have to select the level 0.05, and then the degrees of freedom, that is 2. Alpha level 0.05, it is comes to here, and degrees of freedom equals to 2. Then we can find our chi-square value is 5.991. that is the chi-square value 5.991. what is our calculated value? That is 6.5. right? Decide, reject, or do not reject null hypothesis. Compare the observed values and computed values of the chi-square table with the critical value. So that is same as which we are doing in the earlier lessons. Then if the calculated value is greater than the critical value, it means the table value, we can reject the null hypothesis. Right, here our calculated value is 6.5. it is greater than for the table value, that is, then we can reject the null hypothesis. Then conclusion is preferences are not equally split among 3 car types. It means there is a significant difference between the observed values and the expected value. So this is the conclusion. The conclusion writing is the same as the previous lesson, only thing is the different types of calculations. Now we consider the computing the chi-square in two-way classification. There are several steps in calculating chi-square. Determine the threshold of tolerance for error. So first we have, that is, if we have to consider alpha equals 0.050, sometimes it is given as 0.01. normally we are taking alpha equals 0.05. Total all rows and columns in the data table. To compute the chi-square, consider a study. Investigators classified the adults by obesity and hypertension. So there is this is an example. So then there is a study. Investigators classified the adults by obesity and the hypertension, and that is the table. Obesity is classified as low, average, and high. Then hypertension is classified as yes, no. Then how many cells are there? You can see 2 rows and 3 columns. It means, or 2 into 3, it means 6 cells named as yes low, yes average, yes high, and also no low, no average, and no high. So then you can find the column totals, that O column marginals 133, 134, and 133 row marginals 103 and 297. altogether grand total you can take as 400. Figure the expected frequencies. For any cell, expected frequency is calculated by, this is the, now this is different. Earlier in one-way chi-square the expected values are given, but here you can calculate the expected values. There is a equation to find the expected frequency, that is row total multiplied by column total, then you have to divide by overall total. It means if you need to find the expected value for this 24, it means yes low, what you have to do? Row total. So you have to consider this row. What is the total? 103. And column total 24, then column total is 133. It means you need to multiply it by 103 by 133, then divide by the overall total, that means 400. Then how you can find the expected frequency in here? Row total is 103 multiplied by 133 divided by 400. This is the way of finding the expected value in these types of contingency tables. Right, so this is the way, 103 multiplied by 133 divided by 400. Like this way you can find. We will do one by one how we can find those things. Right, so then we can get this table. Right, I'll explain how we can get this table, and to the following equation. So same equation, right, and which we used in earlier. Then we can find the chi-square value. So we will do this and obtain this chi-square value as 9.65. Right, now we can calculate the expected values. For here we need to find the expected value for year slow 24. It means this one 24. No, we need what is row total? 103. 103 multiplied by then column total. Column total is 133. 133 divided by grand total, that is 400. No, grand total is 400. So then we can take the expected value in here. What is it? 103 multiplied by 133 divided by 400. So that is as 34.25. No, yes, 34.25. So this year's average 33. 33 means this one. Row total is 103, column total is 134, grand total is 400. It means 103 multiplied by 134 divided by 400. So we can write 103 multiplied by 134 divided by 400. We will see what is the value. 103 multiplied by 134 divided by 400, that is 34.51. 34.51. Then 46 is this one. Again row total is 103, column total is 133 divided by 400. 103 multiplied by 133 divided by 400. 103 multiplied by 133 divided by 400. Same thing, no? Then same value, 34.25. Right, now we will consider 109. 109 means this one. Row total is 297, 133, then 297 multiplied by 133 divided by 400. 297 multiplied by 133 divided by 400. Then we can find the expected value. 297 multiplied by 133 divided by 400, that is 98.75. right, 98.75. So now we will consider 101. This one, row total is 297, column total is 134. Then 297 into 134 divided by 400. So 297 into 134 divided by 400, that is 99.450. No, if you round off this, yes, 99.50. 99.50. And last one, 87, that is column total, row total 297, 133 divided by 400. So we can write 297 into 133 divided by 400, then same value, no, 98.75. Now we found our expected frequencies. Now we can find the other row square, no, we will find it. What is our observed value done? 24 subtraction 34.25. now 34.25, then we have to square this, then answer we can take as 105.06. Here 33 subtraction observed value, expected value 34.51, square it 2.28. Expected value 46. Subtraction observed value 34.25, square it, value is 138.06. Next one, observed values 109, subtraction expected value 98.75, then square it 105.06. right. Then next one, expected value 101, observed value 101, expected value 99.5, then square it 2.25. right. Last one, expected observed value 87, expected value 98.75, square this, value is 138.06. 138.06. So now we can find the values. Then what is this one? Square divide by expected value, right? 105.606 divided by expected value, that is 34.25. then the answer is 3.07. And next one, 2.28 divided by value 34.51, that is 0.066, it means 0.67. so 0.006, no, sorry, then 0.07 we can write. 0.07, no, right? Yes, that is 0.07. Next one is expected value is 100, and this value is 38.06 divided by our expected value 34.25, then value is come as 4.03. and here 105.06 divided by expected value 98.75, then 1.06. this one 2.25 divided by 99.5, that is 0.02. Last one, 138.06 divided by expected value is 98.75, then 1.39. 1.39 means 1.40. right, we can write this as 1.40. now what is chi-square equation? Is chi-square equals sigma observed minus expectation squared over expectation. It means you need to find the total of this column. It means so we can take right 3.07 plus 0.07 plus 4.03 plus 1.06 plus 0.02 plus 1.4. that is 9.65. So what is chi-square value is 9.65. This is the calculated chi-square value. We calculated the chi-square value as 9.65. Then interpreting the chi-square value, we now need some criterion or yardstick against which measure is the table's chi-square value to tell us whether or not significant. To read the table's chi-square value, we should know the value of degrees of freedom. Degrees of freedom can be expressed by the following formula. Degrees of freedom is equals to number of rows minus 1 into number of columns minus 1. So in here, number of columns, that is obesity. How many number? That is category. The obesity category is considered low, average and high. It means there are three rows, and hypertension, that is yes, no, there are two rows, no. Then according to our formula, row minus 1 into column minus 1, row is equals to then 2 minus 1, columns are 3 minus 1, that is 2 minus 1 is 1, 3 minus 1 is equals to 2, then 1 into 2, that is 2. That is the way of finding the degrees of freedom. Number of rows minus 1, number of columns minus 1, then you have to multiply those two numbers, then you can take the degrees of freedom. Look at the chi-square table for 0.05 of the degrees of freedom 2. So that is, you can see a same value, that is 0.05, then degrees of freedom equals 2. Then what is our chi-square? 5.991. Then what is our calculated value? That is 9.65. Again, what you can conclude then? Our calculated value is greater than the critical value, so we can reject the null hypothesis, no? Computed chi-square value is 9.65. Our table chi-square value is 5.991. So chi-square calculated value is greater than the critical value. It means the table value. So we can reject the null hypothesis and confirm the claim that hypertension and obesity are associated. It means there is a significant difference. Okay. So this is the way of doing the manual calculation and interpret the data in the chi-square test. Now we can consider how we can do the contingency tables in using SPSS, right? So use the same data related to hypertension and obesity category. So these are the same data which we used to do the manual calculation. Now we are going to do this using the SPSS. The first step, as same as the previous test, we have to write the null hypothesis and alternative hypothesis. Enter data into new SPSS worksheet and name the variables as hypertension's obesity category and results as counts. So you have to enter into 3 columns like this way. So you can enter those data into the SPSS worksheet. Hypertension, yes, 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 no, no, no. Then obesity, low, yes, low. It means you have to enter the cells, no. Yes, low, yes, average, yes, high, and no low, no average, no high. Then these are the counts. That way you have to enter into the SPSS worksheet. Then null hypothesis, there is no association between the hypertension and obesity category. Then alternative hypothesis is there is a the hypertension and obesity category somehow associated, right? It means there is a significant difference between the observed value than the expected value. As this way also you can write the alternative hypothesis. We have our data already in counts. We must make the sure SPSS uses the count column for use observed values. To do this, go to data and select weight cases. First you have to go to the data, then select weight cases and click the weight cases by option, and so you can see this one, then weight cases by count, right? Then select the frequency variable, this one. Then now perform the chi-square test. This first you have to weight cases into count, then click OK. Then you can perform the chi-square test. For that, go to the analyze descriptive statistics, and here analyze descriptive statistics, then cross tabs. Okay, right. So if you go there, you can see this dialog box. Then select the hypertension from the left side box, arrow move into the rows. So this is hypertension for rows, obesity for the columns then, right? Obesity for the columns, right? To follow the options appear down the window, then you have to select statistics. This one you have to select, and this used to perform the chi-square test. You have to select the chi-square test in there. For example, make sure that chi-square option is checked, so you have to you have to select that chi-square test in here, then go to the cells. This option gives alternative way of displaying the data. In this example, we need to make sure that observed and expected values are selected, right? So next format, this is just allows to you change the data into ascending or descending row order, then click OK. Then you can see the output. Before see the outputs, we will go to the SPSS worksheet and we do this example, right? This is the entered data as we discussed in previous slides. So you can enter this data according to this way. Then what are our steps? First we have to go to the data, then weight cases, then we have to select weight cases by, then for frequency you have to take count, right? Then click OK. Okay, then what we have to do, then we have to go to the analyze descriptive statistics and cross tabs. Then we have to select hypertension for rows, obesity for the columns, right, as in the tables, and that is all, no? So rows are the hypertension, obesity are the columns, right? Then we have to go to the statistics, then we have to select chi-square test in here, right? So chi-square test, then click continue. Then we have to go to the cells, and we have to counts, observed values and the expected values we have to select in there. Then click continue and click OK. So then we can get these output tables. There are 3 tables. So then according to these tables, so we found the values. So earlier we found those values. Now we can check whether these values are same or not. So here, what is our our expected values? We will see. Yeah, if 101, if we take 101, where 101, what is our expected value? 99.5. Yes, 99.5. If we take 87, what is our expected value? 98.75. 98.75 means 98.8, right? Likewise, this is our calculated values. Then this is our Pearson chi-square value. We take that, we took the chi-square value as 9.65 exactly. It is coming in and using the this one. Now we will see how we can interpret that this selected outputs tables. You can see this output table. So this is given the n, that is 400, no, that is grand total, and hypertension into obesity, the grand total is given as 400 in here. You may usually ignore this first table as just tells you whether or not any your data have been omitted. So that is only given that missing data is given in there, so you have to just omit this data, first table. And we can go to the second table. So this is the second table, hypertension, obesity, cross tabulation. So our observed value 99.5. so you can compare our manually calculated value and the table value, so you can get this table by using the SPSS, right? Okay, so when we are doing your manual calculations, you have to write in the way we did in I shown to you, right? You have to write all the steps in the manual, because we do in the questions, that is same question is given to do the in manually and the SPSS. It means you can see the SPSS output and write the values. You can't do that way, so you have to write the steps how you can row marginals, column marginals, then divide by grand total, then you have to simplify that and you have to take the value. Otherwise, if you wrote only that values, I will not allow to give you the marks, right? So you have to write the steps then. Then compare the results in the SPSS out table and with the manual calculated expected value. Those are same, no? Then same or different values. So this is the chi-square test value. So you have to take the Pearson chi-square significance value, that is 0.008. It means that is less than 0.05. It means you can reject the null hypothesis, no interpretation. The final total table is output given the Pearson chi-square statistics is 9.65. So p-value is 0.008, that is less than 0.05, which means we can reject the null hypothesis of association between the hypertension and the obesity. This is the way of doing the chi-square test for the cross tabs using the SPSS. Now we learned how we can do one-way chi-square manually, right? Then two-way chi-square manually and using the SPSS, right? These are the references. Okay, now you have the clear understanding about contingency tables. Calculate row totals, column totals and the grand totals and expected values. Now manually calculate the chi-square value. You know how to calculate the chi-square value manually. Read the chi-square values, tables values, perform the cross tabs using the SPSS, and also understand the different output tables and interpret those data. So I think you have clear understanding about the contingency table. This is the last lecture of this lecture series. So it means now you finish the course data analysis using statistical packages. So if you have any problems related to this lesson and all the other lessons, you can ask from me. So I think you have clear understanding about those things. Next, if you have any problems, we can discuss those problems and then we can have the examination. So thank you very much.